All right, welcome back. More factoring trinomials, but this time we're going to have a greater than 1. So we're not going to have a 1 in front of that x squared term. We're going to have some other number. And you can see one right here on the right-hand side of this little table. We have a 2. We have a 2x squared plus 7x plus 6. So what's going to happen is we're going to end up with the same thing. We're going to end up with 2 binomials multiplied by each other, but the first term in each of the binomials isn't going to be the same like we had when a is equal to 1. When a is equal to 1, if it's x squared, we're going to have x and x. But when we have something like 2x squared, we're going to have different first terms of those binomials because we need something that multiplies to equal 2x squared, and we don't want to try and find something that is exactly the same because then we're not going to have integers there. So the process is a little bit different. And if you want to read through what it says on the left-hand side here, you can stop the video and feel free to read through that. But the key thing to think about with this method is we're going to end up with a binomial that has an h and a k in it, just like we did before. We're going to look for 2 numbers that multiply to equal c. But in this case, they multiply to equal c, but then we have to do a little extra work, and they're not just going to add to b, all right? So we have to find a number that's going to go in front of the x here and possibly another one that's going to go in front of the x there. And so that's going to change up the way the adding to b equal b works, all right? And the key thing is this method requires basically trial and error to be able to find the correct answer. And so let's just go through this first example and I'll show you what I mean. So when I say trial and error, what I mean is we have 2 things we have to think about what multiplies to equal that thing, right? So the first one is the a. In this case, the a is 2, so we have to think about, hey, a is 2. That means the factors are 1 times 2, right? Okay, so we have 1 times 2. And then the 6 is 1 times 6 and 2 times 3. All right, and this is where the trial and error comes in. We have to figure out which pair from the left-hand side, fortunately there's only 1 pair there, and which pair from the right-hand side, when we put them in the binomials and we multiply them together, are going to end up producing a 7x for our middle term. And the easiest way to do that is to actually just plug them into the binomials. Okay, and this is where the trial and error comes in. So you might have to plug it in, doesn't work, you got to erase, you got to try another one, and that's okay. So in this case, since we only have 1 times 2 on the left-hand side, that means our first term in the binomial is going to be, and I'm going to put them in the order with the larger number first, if that's okay. Maybe let's do this. Let's just make this 2 times 1, so there's no confusion. All right, so I'm going to put these in here, but remember, since there's an x squared there, we have to have an x in each one of these, but then we're going to have a 2x here and a 1x there. All right, and another thing I can do with this one, since everything is positive in my original trinomial, I know that everything's going to be positive down here, so I can just write a plus sign in there. And now all I have to do is start my trial and error, right? So I can start with the 1 times 6, and let's do that. Let's do that in green. So I'm just going to plug in the 1 and the 6. And then if I think about distributing here, I'm going to distribute this one to that one and this one to that one. So 2x times 6 is 12x. 1 times 1x is 1x. And if we add those together, we get 13x. And that's not what we want, because what we want is 7x. Okay, so that didn't work. All right, so what that means is I'm going to erase those numbers, and I'm going to switch their spots. So I'm going to put the 6, whoops, I erased more than the numbers there, hold on. I'm going to put the 6 first and the 1 second. Okay, so now I'm going to do the same thing. I'm going to distribute here, and I'm going to distribute here. So the whole idea is I'm not doing all the distributing that you would normally do when you're multiplying, binomials, all I'm doing is the distributing that produces the middle term, because I want to figure out what numbers I need to put in there to get that middle term, because I already know that the 2x times the 1x is equal to the 2x squared. And I know that whatever numbers I put in the second position in each binomial are going to equal 6, because I'm only going to use the factors of 6. Okay, 6 times 1 is 6. 2 times 3 is 6, right? So I'm just trying to figure out what numbers can go in there so I can produce that middle term. So 2x times 1 is 2x. And 6 times 1x is 6x. So 2x plus 6x is 8x. Well, that's close, but not close enough. We need it to be 7. All right, so now we need to say, all right, that one didn't work. So I can just actually cross the 1 times 6 off the list. So I can be pretty confident that it's the 2 times 3. However, it's possible that this thing isn't factorable. And if it's not factorable, then it's like, well, none of them are going to work, and that's okay. So let's try the 2 and the 3. So I'm just going to go backwards like this instead of doing the other way. All right, so I'm going to plug in the 2 and the 3. And whoops, I got to cross that off again. All right, so we're going to distribute to find that middle term. And here we have 2x times 3 is 6x, and 2 times 1x is 2x, and 6x plus 2x, well, that's 8x again. That doesn't work. All right. So that means we got to try flipping those around. So we're going to go with the 3 and the 2 in the opposite spots. So here we go. Let's go. Oh, I'm erasing my crossing off again. Here, let's. All right. So what did I have? I had the 2 here and the 3 there. So I need to put the 3 here and the 2 there. Okay. So now when I distribute, 2x times 2 is 4x. 3 times 1x is 3x. 4x plus 3x is 7x. So there we go. I found my answer. So my answer is 2x plus 3 times 1x plus 2. Now, typically we wouldn't write that 1, but I'm going to write it. It's okay. All right, so that's a fair amount of work, and that's what I mean by trial and error. You just have to try different things and see what works. And now some of you might get to the point where you can just kind of look at the 2 lists up on the top and be like, I don't know if there's any way I can plug a 6 in there and multiply it by 2 and a 1 to get to 7. So because when you multiply it by 2, it's going to be 12. It's going to be way too big, right? So if you can get to the point where you can just kind of look at those lists and narrow it down, or maybe pick a number that you think might be the best option, that is something that I hope that you will be able to get to be able to do. All right, let's try another one. So these first 2 examples are nice because the first term only has one set of factors, 1 times 3. But in this case, this one has now 3 factors. So 1 times 12, 2 times 6, and 3 times 4. Okay, so if we just do a little quick thinking here, that number in the middle is 37. And that's a big number. So if it's a big number, I'm kind of thinking we might want to start by trying the biggest number we've got here, which is the 12 and the 1. Okay, we know we're going to use this one for sure. So let's go ahead and just write those in our binomials here. So we have, I'm going to go over to the right here and do this. So we have, and again, sorry, the 1 times 3 is, I'm going to put it in a different order. So it's going to be 3x and then 1x. Let's do this. Okay, so 3x and 1x, we know that needs to be there because that multiplies to equal 3x squared. And then we can try the 1 and the 12. And if you think about 1 and 12, if we put the 1 here, it's 1 times 1, and we get 1x, right? And if we put the 12 here, it's 3x times 12, and 3 times 12 is 36. So we have 36x plus 1x, and that equals 37x. and that's what we want. So we know that the answer to this one is 3x plus 1 times 1x plus 12. Okay, so now the trial and error was a little bit simpler because we kind of thought about it a little bit and said, hey, wait a minute, that's a really big number. So I'm going to try to use the biggest number first. It's not always going to work. You may end up having to go through every single one of these pairs before you figure it out, and that's okay. You'll eventually get to the point where you'll start to see the relationship between these things, and you'll be able to make quicker work of it. Okay? All right. Here's another one. Now, this is one where, unfortunately, the 8 has 2 factor pairs. That's, well, but we're getting lucky here because the 5 has only 1 times 5. Okay, so this one, we can do this one a little differently. We can say, all right, I know that that last term has to be a 1 and a 5. Okay, because there's only one factor pair for 5, so I know it has to be 1 and 5. And then now I just have to figure out what numbers are going to go in the front. I know there's going to be an x, so let's just go ahead and put the x in there. Okay, I don't know if it's going to be a plus sign with the 1 or a minus sign, and I don't know if it's a plus sign or a minus sign with the 5. All right, so that's something I'm just going to have to figure out. So let's see if we can get this to work. Actually, you know what? We do know it's going to be a plus sign or minus sign. You know why? Because the negative 22 is negative and the 5 is positive. The only way to make a positive number, 5, is to have both of them be negative. So we know they're both going to be negative. So now we just have to figure out what number goes next to each x. And the easiest way to do this is going to be to think, if I plug in the 8 and the 1. So if I were to plug in the 8 here, I'm going to be distributing 8 to negative 5, and that's negative 40. And that's way too big, right? So let's say the 8 isn't going to work there. What if I plug in the 8 here? Now it's 1 times 8. That's negative 8x. Well, is that going to work? So if we go 1x, and we go here, so we have negative 5x, negative 8x. Nope, because that's negative 13x, and we want negative 22. All right, so some of you may have already noticed that. Let's get rid of all that. And let's think about the 2 and the 4. So we know that the 1 and the 8 isn't going to work. So let's think about the 2 and the 4. And we want to get to 22. One thing to think about is 4 times 5 is 20. So maybe we should think about putting the 4 here and the 2 here. And 4 times negative 5 is negative 20x. Negative 1 times 2x is negative 2x, and they're both negative, so it's negative 22x. So there we go. We have our answer. Whoops, don't want to do that. So our answer is 4x minus 1 and 2x minus 5. And again, if you ever doubt yourself, set up that box, put one binomial on top, one down the side, and do all the multiplying. So we have 8x squared. That's what we want. We have positive 5 down here in the corner. That's what we want. And then we have negative 20x and negative 2x. And when we combine those two together, it equals negative 22x. So you can always check your work with these. And that's kind of the cool thing about this type of factoring. All right. What's going on with this one? Oh, so this is another example of one where we throw something extra in there. All right, so the extra thing here is just the y squared. I don't want that. Let's do this. It's just the y squared and the y. Because if we ignore the y and the y squared, it looks like a relatively normal trinomial with a greater than 1 that we're going to factor. And if you remember from the last lesson, the only thing that happened when we had that y there is what it does is it introduces something where we have binomials that, since it's x squared, we know we're going to have an x in the front. Since it's a y squared on the end, we know we're going to have a y here. But then we're going to have numbers that go with each one of those. Okay, so that's the only difference that this y squared makes, is it adds a y to the second term in each binomial. So if we just go through this process, we have 1 times 10, 2 times 5. So this is another one. Dang, there aren't any that have like multiple factors for each one. I should find one, make you do it. And then this one is 1 times 3. So there we go. We know at least we're just going to have a 1 and a 3 here. The only problem is, since it's -3 up here in our original trinomial, we don't know which one's going to be positive, which one's going to be negative. So we're going to have to mess around a bit here. And that really makes it a little bit more complex, right? Because now, not only are we going to be plugging in the 1 and the 10 and the 2 and the 5, but we're also going to have to decide, hey, one's got to be positive, one's got to be negative. So we got another thing to deal with here. So let's go ahead and let's think about this first, though. We have a -13 in the middle, and we're going to be multiplying by a 1 and a 3, and we got a 1 and a 10 and a 2 and a 5. I'm kind of feeling like if we do 5 and 2, I don't know if that's going to work. Wait a minute. Yeah, well, that will work. Let's do the 2 and the 5 first, and hopefully you'll see what I'm talking about. Okay, so we're going to go here, and we're going to plug in the 2 and the 5. So I'm going to plug in the 5 here and the 2 here. I'm going to make this one positive and that one negative. So then when I distribute here and I distribute here, I get -15xy and I get +2xy. And when I add those together, I get -13xy, which is what I want. So I got lucky. And part of it is I was able to look at that and figure out, I can see a relationship here, because 5 times 3 is 15, 2 times 1 is 2, the difference is 13, so that's what I want. All right, so it's not going to necessarily be that simple for you when you're first doing these, but hopefully you'll get to the point where it is, and you'll be able to do these pretty quickly. Okay, so there we go. That's our answer. 2x plus 1y, or sorry, 5x plus 1y and 2x minus 3y. All right, one more. One more. Oh, this one is just like one from the other day. It's got an even x term, right? Exponent on the x term. Okay, so the only difference this is going to make is our binomials are going to have an x squared at the beginning instead of just an x. All right, and this is going to be 3 times 1, so we can go ahead and plug that in. And now we just have to decide 1 times 8, 2 times 4. One of them has to be positive, one of them has to be negative. So we could do this, or we could do this. Okay, and so we just have to kind of think about it and say, all right, I need to come up with a 5x, -5x squared. And if I'm looking at these 4 here, and I've got a -1 and an 8. If you think about 8 and 3, the difference between 8 and 3 is 5, right? So let's focus on these here. Okay, so we have 8 and we've got 3. The difference is 5. So let's see if we plug one in. If I plug in the -1, not with that, I need to do it with the marker. If I plug in the -1 there and the +8 here, when I distribute, I get, oh man, no way, 24, right? That's way too big. But let's just flip those around. Let's flip those around and put the, come on, the 8 here and the 1 here. So when I distribute there, I get 3x squared. And when I distribute here, I get -8x squared. And that equals -5x squared. So there we go. That's another way to think about it. Those relationships between numbers, right? So the answer is 3x squared minus 8 times 1x squared plus 1. All right, that's it. And you've got some to try on your own. So again, if you have questions, please let me know.